Hello AP Calculus, I'm back with a new video over 3.6. This is chain rule, and you're going to see a lot of it starting out right now. So, for the first lesson, we've already talked in class about how chain rule works, but I want to make sure we have it documented on video. Chain rule states that if I have a function that can be written as a composite of multiple functions. So let's say that f of x is equal to g of another function. So g of h of x, something like that. In this case, you would say your h of x is the inner function x squared minus 3x plus 8. Whereas, I'm putting them in quotes because the real function's actually listed up there. And then your g of x would be the outermost function, which is basically just the variable cubed. So g of x would be like x cubed. Chain rule states that if you're trying to take the derivative of this entire function, then what you do is you say, only take the derivative of the g, still placing in its x the h of x, okay? But after that, you're going to take the derivative of the inner function. So what does that look like? Well, the derivative of x cubed is 3x squared, but we're not plugging x in, we're plugging h of x, times the derivative of the inside, which would be 2x minus 3 plus 0. And that's how chain rule works. Normally, notationally, we put the simpler functions out front with the bigger powers to the right of it. Yeah, think of it too, as if you have something to a power. It's almost like you're doing power rule where you bring the 3 down, right? And then you repeat the center, take 1 away from the power. You're just now taking the derivative of the inside function. Okay, so now things are escalating quickly. Now we have two complex parts inside of a fraction. So you have to do quotient rule and then chain rule within the quotient rule when we take the derivative. Sorry, that was kind of clunky the way I said that. We have to do quotient rule, we have to do chain rule. Let's get to it. So the bottom times the derivative of the top is how quotient rule starts it out. So I'll do rewrites in black, derivatives in red. So the bottom, unchanged, times the derivative of the top. The derivative of the top will be bring the 3 down, rewrite, and then take 1 away from the 3. And don't forget to take the derivative of the inside. (3x squared minus 1). Okay, this one's going to get a little bit lengthy. It's all right. We'll get through it together. Bottom times the derivative of the top minus the top times the derivative of the bottom. So the bottom is going to be bring the 5 down, rewrite the middle, take a 1 away from the power, and then multiply by the derivative of 5x squared minus 2. So there's the start of quotient rule. Then you take the bottom and square it. All right, so my goal was to give you a challenging quotient rule so that you can really know your ins and outs, not just of this, but of the algebra required on this next move. So on the next move, we are going to factor out what we can on top. So there is a 5x squared minus 2 here and a 5x squared minus 2 there. To factor, we take out the smaller of the two powers. You're going to take out a 5x squared minus 2 to the 4th power. So, in purple, I have factoring going on. I don't know if the purple's going to pick up on the video. So I'm taking out a 5x squared minus 2 to the 4th power. So factoring is the same as dividing something out. So I've just divided this entire group out. This is now replaced with 1. Not 5x squared minus 2 to the 1, but literally 1. This one, when you divide it, takes away every 5x squared minus 2 except one of them. So I'm just going to say this 5 becomes a 1 right here. Now, we can also take out an x cubed minus x. The smaller of the two is the 2. So I'm going to factor it out, getting rid of this completely, but leaving only 1 left over of this group. So now you ask yourself, are there any other factors which I can factor out of this? So this is going to have a 3. This is going to have a 5 and a 10. Nothing else is going to be able to be factored out of it. So at this point, I'll put in black everything that remains on top. So you have 3 times 3x squared minus 1, times 5x squared minus 2. So 3 times 3x squared minus 1 times 5x squared minus 2. Subtracting 50x times x cubed minus x. And all of that is still divided by the bottom squared. In fact, I can use the power to a power rule that you guys learned back in Algebra 1 or Math 1, that you multiply those two exponents to get 5x squared minus 2 to the 10. Now, I picked a really rigorous example. Like the algebra in this is the big stumbling block. But if you make total sense of the purple step and really how we got that step before it, you're fine. This is just going to be kind of a pain in the butt. So, to simplify this algebraically, we can go off to the side and figure out what this is expanded. I'm wondering if I want to actually commit to that. I do. Let's, oh wait, before we do that though, you see the 5x squared minus 2 to the 4th power and the 5x squared minus 2 to the 10th power? You can actually use the rule of dividing these powers of the same base just means you subtract these two. So 4 on top are going to cancel with 4 on the bottom. So you should be left with 5x squared minus 2 to the 6th power, and this is gone completely. If I were to multiply this all out, I get 15x to the 4 times 3, so that's going to be 45x to the 4. I'd have negative 6x squared minus 5x squared, which is negative 11x squared times 3. And then I've got negative 1 times negative 2, which is 2 times 3 is 6. Over here, I've got negative 50x to the 4th power now. And then I've got negative 50 positive 50x squared. So that wasn't so bad. This represents the variable expression in the black brackets. So I think we've got our final answer. It's going to be x cubed minus x squared this simplifies down to negative 5x to the 4 plus 17x squared plus 6. That's going to go right here. And I don't need brackets because there's no grouping symbols here anymore. So I'll just put it in parentheses. All of that is going to be divided by, can you guys see that? 5x squared minus 2 to the 6th power. So yeah, to say that was rigorous may be an understatement, but I hope you guys could see that we pretty much just did algebra. Factoring, multiplication, polynomial expansion, etc., etc. So perhaps you guys want to try the next random example on your own. This will be the last one for this particular video. But pause it and try to get a random example 2 to make sense. All right, you've given it a shot. Let's see how it went. I'm going to take a different approach on this one. Remember how we just did quotient rule? Well, you can always adjust quotient rule to fit product rule if you just use negative exponents. Here's what I mean by that. I could rewrite h of x as 3x minus 2 to the 1 power times, this was a cube root, which is the same as to the 1/3 power, right? Cube roots are the same as 1/3 power. I could multiply this by x squared minus 1 to the negative 1/3 power. If you bring it out of the denominator to the top, then it's a negative exponent. Okay, so now we could maybe just use product rule and don't have to mess at all with the quotient stuff. No fractions tends to make people happy. All right, so product rule is first times the derivative of the second plus the second times the derivative of the first. I'll do rewrites in black, derivatives in red. So first times the derivative of the second, that's going to be negative 1/3. Rewrite the middle. Take 1 away from negative 1/3. So it's negative 1 and 1/3. It's negative 4/3. Times 2x. And we've got our first part of product rule complete. Add that to the second, rewritten, times the derivative of the first, which is just 3. And we're on to the factoring step now. That's where I take purple and ask myself, what's the smallest group of x squared minus 1 that I can take out? Well, technically negative 4/3 is further left on the number line than negative 1/3. This is the smaller number, so it's going to be the one that I'm factoring out. So I'm going to take out x squared minus 1 to the negative 4/3 power. Sometimes this is kind of hard to visualize, but just recognize I'm dividing these terms by x squared minus 1. So I'm subtracting the exponents. So it zeroes out that exponent, leaving just a 1. It makes this exponent negative 1/3 minus negative 4/3 3/3. This is always going to be 1 when you apply quotient rule or product rule. It has that same pattern every single time. So now I think we're pretty much ready to simplify inside the brackets. I don't believe we can take anything else out of this. So you've got negative 2/3 times 3x minus 2, and you're adding 3 times x squared minus 1. So all we got to do now is the algebra. And then sneak this guy to the bottom and make him a positive exponent. So the algebra is going to be negative 2/3 times 3x. These will cancel, and you're left with negative 2x. Negative 2/3 times negative 2 is positive 4/3. Plus 3x squared minus 3. And let me simplify that first before I start doing anything with the purple. Over here, it's going to be 3x squared minus 2x. 4 minus 3 is going to equal negative 5/3. And there's a tricky part to this, all right? If this is nested inside of a fraction, so let's say that I'm over here now. I rewrote the derivative. This is the stuff in the black brackets. I've moved my x squared minus 1 to the denominator and called negative 4/3 positive 4/3. There's technically one last move to simplify this. I want to get rid of the fraction inside of a fraction. So if I multiply everybody on top by 3, it gets rid of the denominator here. But I also have to multiply everybody on the bottom by 3 as well to maintain that whole fraction integrity. So that's what I'm going to do. 3 times 3x squared is 9x squared. 3 times negative 2x is negative 6x. 3 times negative 5/3 is negative 5. On the bottom, I've got that 3 still, and then it's going to be x squared minus 1 to the 4/3 power. All right. Hopefully this was helpful, guys. I'm coming back at you with another video.